So the Connector project is a collaboration between the GCP and some of our industry partners. We're looking at how autonomous vehicles can be brought to Cambridge to support the public transport system. It's interesting, it's different, it is innovative. It's good to do something like this in Cambridge where there are people that are receptive to this sort of technology, but also people that are likely to challenge the theories that we come up with and the tests that we do. We're working with IPG, Automotive UK and dRISK to work on some of the simulations that we could achieve for Cambridge, looking at how we can make our routes safer and more carefully analysed. So IPG are going to build us a digital twin of the bus, and that will be displayed on some of the routes, and dRISK will be looking at risk scenarios around the campus, making sure that we understand where there are high risk areas like pedestrian crossings or junctions that might need particular attention, and we'll hopefully be able to use that to influence some of the testing that we do in real life to make sure that safety is paramount in what we do.
We've decided to do extensive safety testing and validation before vehicles even hit the road.
Our routes in Cambridge have some specific high-risk areas, including the hospital, which has a lot of emergency services, perhaps people crossing with wheelchairs or walkers, those sorts of things. But also Cambridge is very well known for its cycling community and the large number of cyclists and cycleways. So we've made sure that there's particular attention paid to cycling edge cases, and also that the autonomous vehicle completely understands where the cycle lanes are, the cycle crossings are, those sorts of things.
The opportunity to work with IPG and dRISK means that we get a much clearer overview of the route itself and the safety items that we should be looking at. But it also gives us the opportunity to provide the local residents and businesses with information and locations that they recognise in a virtual world, so they're able to see really what this is going to look like as they move around.
Virtual test driving enables the seamless development, calibration, verification and validation, all in the virtual world, of a total vehicle with all of its control systems together. For the Connector project, our engineers have created a digital twin of the Alexander Dennis electric autonomous vehicle, that bus. And we've put that bus into our virtual environments.
So we aren't using simulation instead of physical testing. What we're going to do is use the information that we get from looking at the simulations of both the routes to understand where those high risk areas are and how the system responds directly to it. And then we'll also use that information to influence what we test on the physical track. So we're really excited to be bringing the Connector project to Cambridge to understand how we can safely integrate this sort of technology into our local public transport system to better benefit all our local residents.